Okay, so I'm going to show you how to do the spot grades for the center line of the road since we've got our surfaces. And I'll double check with them just to make sure, you can have these switched however you want to look at it visually. So I'm going to come up here and go to the annotate, click on add labels. I'm going to go ahead and close that. And then I'm going to come and go to surface, and I'm going to do spot elevations. Elevation only. I'm going to add. Now I'm going to press the enter key to get a list, and I'm going to look at surface A first. Now I am going to use the nearest command. So just make sure nearest is highlighted, turn it on. And I am going to do this point right here. I am going to do this point right here. Those two are going to be based on for my elevation of the buildings, because I know there's a low point right here. I could click on a point here, 79, 88, 80, 81, 33. So my finished floor is going to be based on these high points here, the 81, 53 and the 80, 03. All right, I am going to escape out of that, and I'm going to go ahead and put these on the no plot layer. All right. Now, I also want to adjust these elevations to make them a little bit smaller, the style. So I'm going to come up here and click on the editor, and I'm going to change that height to 0.07 and the layout to 0.07, and I'm going to turn a radius of 45. Okay, so in the layout of the elevations only, text height of 0.07 at a 45-degree angle, drag state, make the arrowhead 0.05, and the text height 0.07. Apply and OK. All right. Now, so that's going to give me the elevations here on street A. So I'm first going to look at the finished floor of my buildings. So my building is basically going to encompass this block right here. All right. So I am going to also make sure, I'm going to copy this. From the center, I just want to double check to make sure my information is correct. So at 1350, 80 point, okay. So I feel good about that. And let's move this down. I'm going to do midpoint to here, 1860. Let's look at 1250. 8110. Okay, so I feel good about my surfaces being accurate now. So 12 should be 8205. 8205. Okay, so that looks good. Now we'll also have elevations in between these two in the center here. I'm going to leave that one over there for right now. We're going to start with our buildings. So I am going to copy this piece of text. And so I'm going to go, actually, I'm going to use this piece of text here. Copy that. Come over here. Double click on it. And we're going to say the finished floor elevation dash, it's going to be 82.53. because that's 2.5 feet above the center line. And the center, let me pull this down. And the center line is going to be 80.03. All right, and it is going to be an A drainage. Okay. Now, I'm also going to, I want to create some spot grades on the front and the rear lots, okay? All right, so I'm going to add, to make my life a little bit easier, I am going to add elevations, hit enter on alley A, and on alley A, I am going to use my endpoint, and I'm going to hit an endpoint. Yep. Here, 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 because I need to know what my garage slope is going to be, so I need to know what those elevations are. So I'm going to go ahead and put these here. Now, I also want to check out to make sure my information is correct. I'm going to go perpendicular. Okay. So I'm going to go and look at, I'm going to check to make sure the corridor did the math right. I don't want you to do all the work and find out the information is correct. And I don't like this symbol. So I'm going to select similar, and I'm going to change that to just a basic. Okay, that's better. All right, so 8156, and I'm going to copy this point from the end point here to the end point there. I just need to see if the math makes sense. My assembly worked. So I have 81.36, and I'm going to add 8 feet at 2%. Actually, it's 8 feet and another 2 feet. So that's 10 feet plus 10 feet at 2% gives me 8156. And that is a half a foot at 1%, so you're not going to see it. So 8156 is perfect, okay? So my assembly worked on the alleys. All right. I don't need this one. Now you would want to go ahead so you can see these. I'm going to turn off my O-snaps and bring them down as such. Now, since each one of these has its own driveways, you would possibly need to put spot grades at every lot line. These are townhomes, so this is going to be one building, and the lot lines represent the interior building line. Okay. All right. You could also pull them down however it looks. I'm not going to worry about that right now. Right now we're just learning how to do the math. So on this one, I want to go ahead and make this look good. So I'm going to go to this over here. Like if I double click on it, highlight the text, you can use this button right here to make it go center. Now I'm going to put the front lot grades on everything else, on surface A. So add and hit enter or the space bar and go street A. And then I'm going to hit my O-snaps here, 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 here. The nice thing about using the Civil 3D is it automatically updates. So if I changed my alignment, all these numbers would update automatically for me, which is pretty fantastic. All right, so those are all done. Now, I also like to put spot grades at the intersections of these to make sure that everything drains properly. So I'm going to go ahead and add those here. I am going to copy because alley A controls this side. Home, copy, end point to end point to end point to end point to end point. Okay. Now, the reason I do that is to make sure that water drains properly around the curve. Now, since our high point, if we're looking at this, since this is the high point here, the water has to drain around this point, around this curve, into this inlet. Okay, so I'm just making sure that water drains properly. Now, so 80, 90, and 80, 29 definitely gives me enough slope to get water around the curve. And since this is a high point, I don't need a valley gutter to send water if it was a continuous grade, like on this side. So over here, I can see the PVI. This is a continuous grade down this direction to the low point here. So I need to look at the elevations here. Okay, so at this curve return, at this PCPT, I can see that it's 80.88 and 80.13. Typically, you want to have at least 0.4% slope. Now, in this one, see how it's only 0.88 and 80.70? So that means I would need polyline, endpoint, to endpoint, offset 2. I would need a valley gutter offset here. So I'm gonna match the properties and put this on the back of curve just to, oops, MA. Okay, just got to make sure this drains. So this distance is 2356. Okay, I paused doing the calculations because I always want to make sure my intersections work properly before moving on in case I have to change something. The calculations of the finished floor should always be your last thing, because if you start manipulating the elevations of the road again, then you're going to have to redo all the calculations. So that's why I paused to do this first. Okay, so this curve return is 2356. So I have 80.88 minus 80 point, what was it? 70. So that's only 0.18 divided by 23.56. That gives me a 0.76% slope, which is fine. So water is going to drain this direction, and then it's going to drain down. Okay, and this one's going to automatically. So I need this little valley gutter to keep this water, when it drains this direction, to slide this direction. Okay, now here's the other thing. This is an inverted crown, so technically the water is draining to this the midpoint anyway. So if I copied this here, from here to perpendicular to here, we could see that I'm draining down to this point anyway. So I like the valley gutter here. The valley gutter is just a little, kind of almost like a V sway, a V concrete. I'm sorry, a concrete V. Now let's go ahead and take a look at this one. So I'm going to put my spot grades up here. So surface street A, snap to these points here. I'm going to put it here on this point, and I'm going to put it here on this point, here on that point, and that point. So if I look at this, I've got 8165 and 8240 minus 81.65 divided by the length of this curve is 39.27. So the slope is almost 2%, 1.9. So I'm fine there. So water, oddly enough, it drains this direction, And on this side, it drains this direction. So we'll need to do a valley gutter here. Offset 2. And I'm going to match properties here. All right. Now, I'm going to trim this up and show you something. So typically what a valley gutter does look like, drafted, looks like this. Oops. I'm going to extend. And now I'm going to trim. I'm just going to delete that. So the valley gutter would come along this baseline through here. Okay. So it would look like that. All right. So we have a 83.61 minus 82.33, and that gives me, divided by 39, gives me almost a 3% slope. So these are pretty steep slopes here in Florida, okay, at least up here in the Orlando area. All right, now, so I've got all those spot grades. Now I'm going to take a look at the finished floor elevations of, so I've got the finished floor elevation here, and I'm going to copy this and put it over F3 here. So this one is going to have an elevation of 81.33. .33, so that gives me a 83.83. Okay, for the finished floor elevation. Now, we would need to take a look at the driveway slope. Oops, that's not what I wanted to do. All right. Control copy. Let's see if I can get that to paste correctly over here. There we go. I did a piece of text over on a different drawing. I'm just going to do this simply. So let's say the garage, that's some bad math. That should be 82.53. Wow. So we go 82.53 because it's 2.5 feet higher than the center line. So here's an example of the math. So if the garage is 82.53 and it's a 1/2 foot to the step down, so that's 82.03, then 82.03 minus the lowest, if I look through here and the lowest is 80.94, then what is the driveway slope? Okay, so 82.03 minus 80.94 divided by 25 is 4.36%. So that's fine. That is fine. I put this also on a no plot layer, just FYI. And then let's take a look at this one. So I'm going to copy this over. You do not have to, this would not be put into your drawing. This is for me to show you how I did the calculations. So if this is 83, then this would be 83 point, because it's a 1/2 foot drop. .33. So 83.33 minus, and my lowest elevation here is the, I'm going to go with 80.88. So 83.33 minus 80.88 divided by 25 gives me 9%. which isn't ideal. 9.8%. But it's less than the 10. Okay. Make sure I did those right. 82. So the center line is 80. So that's right. Okay. So this is worst case scenario. This driveway has almost 10%. This driveway would have less. So it would be, the finished floor would be, or the garage would be 83.33 minus 81.14 divided by 25. So that would be 8%. So this one has a steeper driveway slope than this side. This one would have 82.03 minus 81.37. That's this elevation right here, divided by 25. That'd be 2.64. So that's what this is saying. Now here's the problem. Between this finished floor and this finished floor, I have 2.53 minus 83.83. 1.3 foot drop in a 10-foot area. Okay, I may end up losing a lot if the developer doesn't want to put some type of retaining wall in on this side, because that is a 13% slope across this area. That's not horrible. It's just sending all the water to the side of this building. Okay. Now, I'm going to pause here, and then we're going to take a look at the finished floors through here.